Hey, my 130s. In this video, I'll be covering homework alternate chapters 8 and 9, intro into logarithmic functions, which will cover numbers 13 through 17. Essentially, remember before we were looking at exponential functions. Let's find a good color for this. This was the last video. What we're going to find is that exponential functions and logarithmic functions, are inverse functions of each other, okay? So kind of remember from before how we would find inverse functions. Let me actually save this and then do a new share of the whiteboard. Okay. Okay, so recall, suppose we have an example like y equals, actually not y, come on. Okay, if we have f of x equals 3x plus 5 over 2, we want to find the inverse function. Okay, remember the steps. We would change f of x to y. Okay, then we switch x and y. And then we would solve for y. So 2x equals 3y plus 5. 2x minus 5 equals 3y. 2x minus 5 divided by 3 equals y. Okay. So y equals 2x minus 5 over 3. Okay. And then we would change y to f inverse x. Okay, remember this is f inverse x. So what we get is that f inverse of x is equal to 2x minus 5 divided by 3. So this is our original function here. It passes the vertical line test. Okay. And then the inverse function we get would pass the horizontal line test. Yay. Okay. All right, now these will be one-to-one functions. So we'll also find out that the horizontal line test and vertical line tests are passed for both of them. But don't worry about that technicality. Just want you to think about how we did the process of getting to an inverse function. Okay. And then remember also, if point AB is on the graph of F, then the point BA will be on the graph of f inverse. So let's just choose an x value. Let's say I choose x to be 1. So 3 times 1 plus 5 divided by 2. That gives me 4. So I know that the point 1, 4 is on the graph of f of x. And you can plug that in, just check it. Okay. What does that tell me about the point that'll be located on the inverse graph? That tells me 4, 1 will be located on the inverse graph. So that's just review. Okay. Early chapter 8. Okay, so let me clear all this out right quick. Sorry, it's taking me a minute there. So easy to get distracted when you're doing things on a graphics tablet in front of a computer. Okay. All right, so now what I want to get into is exponential functions versus log functions. You're going to see me abbreviate this as log, just to let you know. Okay, so remember, for an exponential function, we're going to have something like f of x equals a to the x power. Okay, let's color code this a little bit like we did before in the last video. F of input x is going to equal your base of a to the x power. Okay. Now, there's one more thing I want to do. We'll come back to the function form of this, but I want to make this y equals a to the x power. So it's a little bit easier to see how we're going to go into log form. Okay, so what these guys here are called, these are the exponential forms of your function. When you change this to a log form, first thing you're going to want to do is write log. And let me keep this in purple so you know that it still has to do with the function part. Okay. Whatever your base is, base A, that's going to come down here, right below the log. Put an equals here. Now, actually, let me not color code real quick. Sorry. There's a reason why I'm thinking about that. Okay, so let's try this just in black for a moment. Okay, so I'm going to put my log. Your base is going to go right below log. Your exponent is going to go on the other side of the equal sign. And then your y value, which is called the argument, is going to go right here next to the log. Okay. So this is going to be, let me go over these parts. Y is called the argument. A is called the base. X is called the exponent. Okay. Notice your argument moves. We're still going to call this the base. And X is still technically the exponent. Now let's color code. Okay, so let me move this line down a little bit. And I'm going to want to emphasize that this part here is your log form. So I think whenever I explain this section, it's typically the same. It's one of those things where I'm like, wait a minute, there's two things that I want to chat about here. One is just how to go back and forth between log and exponential form. Okay. And then the next one has to do with how we would actually get an inverse function out. So let me just clear this part out for a moment right here. And then I'll actually just clear this out too and just write it later. Okay. So let's give ourselves a purpose. How to go back and forth between log and exponential form. And this is how. So let's just look at a quick example before it gets too much more confusing. Let's look at the exponential form. Of, let's do 5 squared. What is 5 squared equal? Well, that's 25. Okay. Note that 25 in this case would be your argument, your base would be 5, and your exponent would be 2. So if you're trying to get to log form, you're going to have a log. Put your base right below that log. Put the argument right next to the log. So log and 25 should be on the same line, but this little 5 should be a little bit below both. And then you're going to set that equal to the exponent. Okay. So what this is saying for the exponential form is if I take 5 and square it, then I would get 25 for my argument. If I look at the log form, I'm saying if I take the log of 25 with base 5, I get 2. What does that mean? That means that the exponent I need to put on the 5 to get a 25 must be 2. Okay. We'll look at more of this in a little bit. As a matter of fact, I want to skip to an example now. Yes, I do. Okay, so before I go into the next part about the how to find your inverse function, I kind of wish I didn't do that yet then. But you know, this is how it goes, right? When you do takes and stuff with these videos. All right, so let me save this and then let's do a new share. Let's go back to our notes. So before we get too crazy, I want you to note that we have, excuse me, for number 12, an exponential form. And we're being asked to rewrite this as a log equation, so in log form. So we're going to put our log form over here. Okay, so go ahead and start with your log first. Then I want you to think, well, what is my base over here? As a matter of fact, but let's rewrite it. Totally hating the way I'm doing this video. Sorry. Thanks for bearing with me. Okay, so I remember our form was a to the x power equals y. And that's going to change to log base a of y equals x. Okay. First, we're going to be moving things around. What's our base in this case? Our base is 3. So we're going to put the 3 right here below the log. What is our argument? The argument is going to be the part alone from the exponential form. So that's y. So we're going to put 1 over 81 right here next to the log, a little past the 3. We're going to have our equal sign in there. And then on the other side of the equal sign, we put whatever the exponent is. The exponent is -4 in this case. Okay. Save a picture of that. And clear. So we found here that what you should write here is log base 3 of 1 over 81 is equal to -4. What that's saying is the exponent that I would need to put on the 3. Okay. So I would need to put an exponent of -4 on the 3 in order to get 1 over 81 out, which is true. Okay. All right, let me clear that out. And then we'll do one more, number 13, before we go back and start talking inverse functions again, finding them formally. So for number 13, you're asked to evaluate a certain log expression. You don't have an equation in this case. So my hint to you whenever you have this, remember this is going to be a formation of a log form. So what you can do is just set this equal to any value you want, like any variable you want. I'm going to set it equal to x, just to keep the same form that we've had so far. To form a log equation. Okay, now when you do that, note you have this log form, log base 3 of 1/27 equals x. Okay, and you're going to want to get this into exponential form. To find x. Okay, because remember, you want to know what this is equal to. So you're setting this expression equal to x. Solve for x, and you'll know what the expression equals. Okay, so remember, this time I'm not going to color code. I'm just going to do it the way that I would typically do this, which is much faster. Find my base, that's 3. Go across the equal sign, that's my exponent. Put an equals between whatever's here is called the argument. Put that on the other side. Okay. To solve for x, this is actually not a bad one because you can get both of these sides to have the same base. Okay. So to find x, match bases on left side and right hand side of your exponential form. Okay, so we have 3 to the x on the left side, right? So let's try to get a base of 3 on the right side by manipulating this. So 1/27, that's 27 is 3 cubed. So this is actually going to be 1 cubed over 3 cubed, which is 1/3 cubed. We still don't have a base completely of 3, right? So use your knowledge of negative exponents to help you here. That's going to be 3/1 to the -3rd power, which is just 3 to the -3rd. Okay, now, because you have one-to-one functions here, for your exponential form, you would have a one-to-one function. So as long as your bases match, you just need to match the exponents. If bases exactly match, then match exponents. Okay. X is going to equal -3. Okay. Save a picture of that. Erase this top part here. So what we found is that log base 3 of 1/27 is -3. Okay. All right, let me clear this out. And then I actually want to go back to the whiteboard now. So I want to show you another detail here, okay? So let's change our question up. I wish I knew how to clear all of this without clearing every single detail. Okay, so our new question is going to be, can we, okay, so it's a little abstract, but it's going to help us out shortly. We're going to find the inverse function formally to see how we get a log function out. The tricky part is when you have the domain range flip. If you're doing exponential to log form, you see the domain range flip here. Okay. X is in the domain on this side. Okay, and then Y is in the range. But if you go to a log form, you can see that now X is in the range and Y is in the domain. Okay, but remember, when we use functions, we typically have f of x and f inverse of x. So we're going to want to keep x in the domain. So we're going to see how to do that by finding the inverse function for here. Okay, let me save a picture of that and then clear this. Okay, so first let's note that this indeed is an exponential form. And to be specific, for this one, it's an exponential function. All right, so what we're going to take the steps of finding the inverse. We're going to change f of x to y. And then we're going to be solving for x. That's not what I want to do. Okay, let me start that part over again and actually write it out so less mistakes. Change f of x to y. Second step, switch x and y. This is important for keeping x in the domain. And then we are going to solve for y. Now this is going to be a little bit different for you because you probably haven't seen it done yet, but essentially when we want to take an exponent down, we're going to do what's called taking the log of both sides. So I'm going to take log of x, and then I'm going to take log of a to the y power. Okay. Next, I have this log of x on this side. We are going to find, I guess I kind of got a little ahead of myself, which we'll find out later. This is going to be a log rule that you actually can take the exponent down and put it in front of the log. And then to solve for y, we would just divide both sides by log a. I'm just going to keep it the same color. It's easier. Okay. Now, there's actually something about this part that I would like to add too, which is going to come up very shortly. Change of base formula for logs. You have log of x divided by log of a. That's the same thing as log base a of x. Okay. So what we found here is that y is equal to log base a of x. Bear with me. If you haven't seen it yet, just watch the steps, and you can go back and review once you see some of the later stuff we covered. So now the last step when you are finding your inverse function is to replace y with f inverse x. So we get from this back to orange, f inverse x equals log base a of x. So let me save that and clear the majority of this. This is definitely giving me ideas for what I want to do for future videos in terms of how I want to break this up and which parts I want to put first. Okay, so essentially the inverse function that we wound up getting here is this one. Come on, there we go. There we go. Okay. So now for the exponential form, if you have y equals a to the x power, its inverse function will be y equals log base a of x. What this does, it keeps your x value inside of the domain, and it keeps your y value inside of the range. Okay. So now if, again, the point AB is on your original exponential graph, then the point BA will be on your log graph. Okay. Let's go ahead and go back to the note guide. So we can see a graphing problem here. We're asked to graph the logarithmic function g of x equals 1 plus log base 3 of x. So the first thing I just want to start with is this portion. So let's even call it something different. No, let's not. Okay, so let's do this. We're not going to plot g of x yet. We're just going to look at log base 3 of x. To compare that, we're going to look at 3 to the x power. So essentially, this is your exponential version of this function. These guys are inverses. So kind of the way it helps you, you're already comfortable finding exponential functions because you're just plugging an exponent in and evaluating. But you're not comfortable with logs yet. So what we're going to do, we're going to pick -2, -1, 0, 1, and 2 for x for the exponential version. And then we're going to plug in. So when x is equal to -2, I would get 1/9. Sorry, hold up. Let's do that down here, make sure. I have 3 to the -2 power. That's going to be 3 over 1 to the -2, which is 1 over 3 to the 2, which is 1 over 9. Okay. When x is -1, we get 1/3. X is 0, we get 1. X is 1, we get 3. X is 2, we get 9. Okay. Let's reposition this so we see how it ties in. Be underneath. Remember, these guys here are inverses. So if A, B is on the exponential graph, then B, A will be on the log graph. So we're just going to switch the x and y values, switch the domain and range. Okay, so we found what these log values are. Now let's do this in a separate color. Let's go deep blue. One plus, and then this part we did in orange. Okay. So we're actually going to be using the same x values. The reason is because when we plug in those x values, we get nice log values. And then for g of x, what we're doing, we're saying, okay, well, I have my 1 plus, what is log base 3 evaluated at this particular x value? We found log base 3 of 1/9 is -2. Okay. Repeat the process for the other one. So 1 plus 1 plus 1 plus 1 plus. Then we're just filling these guys in based on the table over here. So -1, 0, 1, and 2. And then simplify. So give me 3, 2, 1, 0, -1. Okay, save a picture of that, and let me get rid of all this nonsense over here. Okay, so the points we're going to be graphing. 1/9, -1, 1/3, 0, 1, 1, 3, 2, and 9, 3. For this, I would actually highly suggest, if this didn't really click with you, watch this section in Alex, because it might be more helpful for you to do through transformations if you like transformations. All right, let's do our best to plot this with this tablet. So let's start with the bigger numbers for x, because the smaller ones we're going to see, we're just going to make approximations as we lower. So we have 9, 3. That's 9, 3. We have 3, 2. We have 1, 1. We have 1/3, third of the way, 0. And then we have 1/9, which is smaller than that, -1. So it looks like this. Ah, come on. And then steep down this way. You're supposed to be approaching the asymptote but not touching it. There's actually a vertical asymptote here. Okay. So this is what your general log graph looks like. All right, and then one more thing I want to mention about this, like say you were just graphing function f of x equals log base 3 of x. Okay, then essentially, like if you like the translation part, you're just taking this plot and moving it up by 1 unit in order to get g of x. So you can just move all these down by 1 unit to figure out what f of x would be. So this is f of x, and this is g of x. Okay, I kind of think I should split this next part into a separate video for the log rules because it's going to be a significant bit to add. So I will wait on that part. We will go ahead and wrap up this video and I will make a separate recording. So far in this video, we've gone through numbers 13, 12. Try to line it again. So far, number 12 through 14. Plus lecture. All right, stay tuned. There will be more videos later.